Hello students, let's solve one basic numerical based on a piecewise function. Now this is a discrete mathematics question from the function part. So suppose the z, the integer functions. So let f be an integer function that z belongs to all integers is defined as f of x is equal to x plus 1 when x is even here, and x minus 1 if x is odd here. So we have to prove that whether it is injective. This is an application. We have to solve that whether it is an injective function or just will be solving with that. Let's just see. Let's go for your solution part. So in solution, what we are going to do, we are going to try the various values of the values. Procedure will be trying some of the values. Let's try some of the values. Suppose f of 2 here. What will be f of 2? Let's go for f of 2 as 3, f of 4 as 5 there, f of 3 as 2, and f of 5 as 4. These are some of the values what we are going to try or what we are trying over here. Now with this is your first point. Now let's go for second step 2. Now in step 2, we'll be trying here to know two different values. If you'll observe there, no two different inputs map to same output. You know what I mean to say? No two different inputs. Now suppose if I'm taking this part as f of 2 here, we are getting 3 here. And f of 3 is 2. F of 4 it is 5, but f of 5 is 4. So no two different input map to same output. Different inputs. The input is different, but the output should be same. It is not observed over here. Output is not at all same. So as a result, now we will test this. This is the first part. And the first step, we are getting this part of result when you are substituting these values in the given equation. Now you are well aware just how we are getting just f of 2 means it will be x plus 1, so that will be 2 plus 1, that is 3, like that. You are well aware of this. This will x is even. And for odd, if you will be taking this value here for odd function, that will be 3 minus 1, that will be 2 here. So like that you will be getting these two values. That you are well aware that we are substituting the various values and getting the answer for the function here. Now let's test algebra. Algebraically, we will be testing with f of x1 here. Now let's say f of x1 is equal to f of x2. We are assuming that. Okay. What will happen? Consider all combinations now. All combinations of even and odd. What you'll be getting? If you consider all combination of even and odd, we are eventually what we get, we'll get that f the function is injective. If you are assuming an all combination even and odd, you are getting the function as injective here. So what is the reason? Because if you'll observe this part here, in this case, f of 2, we are getting 3, and f of 3, we are getting 2 there. And with the another example, in this, if f of 4 is your 5 and f of 5 is your 4. So from this, we can come to f of x1 is equal to, consider all combination of evens, even and odd, f of, now this is your even combination. F of 4, this is your even combination. And so now if we test algebraically, we'll assume that all combinations are even and odd. So eventually we can say that we get function is as an injective function. So this function, we'll call it as an injective function. Okay, thank you.